Hello friends, and once again welcome to Pankaj's Echelon tutorials. And today we are going to continue from question number 44 where we had left last time. Okay, so let us get started. And as you know, this is from our David Renner book, the fourth edition. Okay, it's a book, old book. Okay, and we are on to the chapter number 9. The name of the chapter being Matrices and Transformation. Once again, Matrices and Transformation. And we were on exercise 1, and we have already completed till now 43 questions. Okay, so today I am going to start with question number 44. Okay, now question number 44 says that uh, okay, you have a matrix which is 3y, 3z. Okay, and then you have 2y plus 4x, and you have a 2z over here. Okay, this is equal to 6, minus 3, 8, and a w. Okay, so this is the question, and you are asked to find out all the unknowns. Okay, find all the unknowns. Okay, so which are the unknowns over here? There's a x, there's a y, there's a z, and there's a w. So there are 4 unknowns that you have to find out. Okay, so since these two matrices are equal, okay, the corresponding elements, that is this and this, will be equal. So can I write 3y equal to 6? This in turn will give me y is equal to 6 upon 3, which is equal to 2. So I get y equal to 2. The first unknown ka value I have got. Then what I will do is this 3z I will equate to minus 3, because these are again the corresponding elements of the equal matrix. So 3z is equal to minus 3. This implies that z will be equal to minus 3 upon a 3, which is equal to minus 1. Therefore I can write z is equal to minus 1. Okay, so I got y, I got z also. Now, yeah, now let me equate this 2z with a w. 2z will be equal to w because they are corresponding elements of the equal matrices. So this implies that now since z value I got just now, it is minus 1. So 2 times minus 1 will be minus 2. So minus 2 will be equal to w. So I get w equal to minus 2. So one w ka value I got. Now I suppose I am left with only x to be found out. So what I'll do is I'll equate this element of this matrix with this corresponding element of the another equal matrix. Okay, so it will be 2y plus a 4x is equal to 8. Now since I have found out y, it is 2, so it will be 2 times 2 plus 4x equal to 8, right? So 4 plus 4x will be equal to 8. 4x will be equal to 8 minus 4, which is a 4, and x will be equal to 4 upon 4, which is equal to 1. Okay, so now I get all the answers of the unknown, starting from x equal to 1, y equal to 2, and z equal to minus 1, and w is equal to minus 2. So these are my answers for the question number 44. So let me check the answers behind and confirm. So the answers for question number 44 behind are given to, I can see them as y is 2, yeah, that's correct. Z is minus 1, yeah, that is correct. X is 1, yeah, that is correct. And W is minus 2, yeah. So all the answers of mine are correct. Okay, now let us quickly come to question number 45. 45th question says that now you have a matrix 2 and a E, and then A and a 3. Okay, then you have plus K times, you have a 3 and a 1, and you have 0 and minus 2, and this is equal to, there's a 8 and a 8 over here, sorry, there's a 6 over here, 8 and a 6 over here, and you have minus 3 and minus 1. Okay, yeah. So now here the unknowns are, of course, there's a E, there's a, and there's a K. Okay, these are the unknowns that you have to find out. E, A, K, these are the unknowns. Okay, so let us work out first. So this I'm going to write as 2 E, A, and 3 as it is, plus, now this will be scalar multiplication, so this K will get multiplied by each and every term of this matrix, each and every element of this matrix. So it will be 3K, this will be 1K, or rather K, this will be 0 into K, 0, and this will be minus 2K, and this will be equal to 8, 6, minus 3, minus 12. Now let us add these two matrices. Since the order of both are same, we can always do the addition. So corresponding elements you have to add. So it will be 2 plus 3K, then E plus K, then A plus 0 is another A, and 3 minus 2K. Now this is equal to 8, 6, minus 3, minus 1. Now the two matrices are equal, so you can always equate the corresponding elements. So 2 plus 3K is equal to 8. This will give me 3K is equal to 8 minus 2, that is 6, and this will in turn give me K is equal to 6 upon 3, which is equal to 2. So I get K is equal to 2. So I got K. Now A I want, so A is straightforward. A is equal to minus 3, no problem in that. So I got A also, A is minus 3, and now I am left with what? E. Okay, so can you see this E plus K I can equate with C. So E plus K, E plus K is equal to 6. Now since I have got the value of K as 2, I'll put it over here. So E plus 2 equal to 6. E will be equal to 6 minus 2, which is equal to 4. Therefore E is equal to 4. So all the three answers I got. So my final answers will be K is equal to 2, then A is equal to minus 3, and my E is equal to 4. This is my final answer for question number 45. Okay, so let me verify the answer. For question number 45, the answers are A is equal to minus 3, perfect, E is equal to 4, perfect, K is equal to 2, perfect. Okay, so 45th question we are done with. So let us move on to 46th. So question number 46. Okay, now 46th question is this. You have a 4 and a 0, you have 1 and a m. Okay, this is first matrix multiplied by np minus 2, 0, and this happens to be equal to 20, 12, minus 1 and a q. Okay, so I'll work out this product. It's a 2 by 2 matrix multiplied by 2 by 2 matrix, so the product will also be 2 by 2. So I'll do it directly. First row, first column. Okay, first row and then this column. 4n plus 0 into minus 2 is 0, so this will be 4n. Then first row, second column, it will be 4p, and 0 into 0 is 0, so it will be just a 4p over here. Then second row and the first column, so 1 into n will be n. Okay, and this will be minus 2m, minus 2m. Okay, now I'll have to write it properly. Okay, this was my 4p. Okay, and this last element will be 1 into p is p plus m into 0 is 0. So that's it. This is equal to 20, 12, minus 1 and a q. So here the unknowns are p, q, m and n. Okay, so you have to find out p, q, m and n. Right. So what I'll do, 4n I'll equate to 20. That gives me n is equal to 20 upon 4, which is 5. I got my n. Next what I will do is, this 4p I'll equate to this 12. That will give me p is equal to 12 upon 4, which is equal to 3. So I got my p also, 3. Okay, and I got p I got. Now I'm left with uh, q and m. Okay, now what happens, these two are equal, p and q. P is equal to q, and since I have found out p, which is equal to 3, so my q will also be equal to 3. So I got my q also equal to 3. P is 3, q is 3, n is 5. Now I am left with only m. So let me equate this particular element to n minus 2m equal to this. I can equate with minus 1. So n value you have found out, it is 5. So 5 minus 2m is equal to minus 1. Now this 2m, I'll bring it on this side, so it will become plus 2m. This 5 is over here, and this minus 1 I'm bringing here to make it plus 1. So 6 is equal to 2m. This gives me m is equal to 6 upon 2, which is equal to 3. Okay, so I'm getting m is equal to 3. So all the answers I've got now. Okay, so let me write them together. Answer will be p is equal to 3, q is equal to also 3, m is equal to also 3, and n is equal to 5. Now these are my answers for question number 46. And in the book for 46, the answer is m is equal to 3, n is equal to 5, p is equal to 3, and q is equal to 3. Perfect. So these are the answers which are very much matching with our answers. Okay, so that was question number 46. Let us quickly move on to question number 47. So question number 47 is this. Okay, it says that if A matrix is 1 0 3 2, okay, then B matrix is x 0 and 1 and 3. Okay, then moreover it is given that AB is equal to BA. AB is equal to BA is also given. Find x. Okay, so the matrices A and B are given to you, and he is saying that AB and BA both are equal. Okay, so let us find out first AB. AB will be, you'll have to write the matrix A first. The order should be proper. A and then the matrix B. Now this product will be what? This is 0. Okay. This is 0. Okay. So the product will be what? First row, first, it will be a 2 by 2 matrix. Okay. So first row, first column. So x into 1 is x plus 0. So x only. Then first row, second column will be 1 into 0 is 0 and 0 into 3 is 0. So this will be 0. And second row and first column, this will be 3x plus 2. And this will be second row and second column will be 3 zeros are 0 and 3 twos are 6. So that will be a 6 over here. So I get this AB as x0, 3x plus 2 and a 6. Now let me find out BA. BA will be, I'll put the B matrix first, that is x0, 1, 3, and then I'll put that A matrix, which is 1, 0, 3, 2. Now the product of this will be, first row, first column will be x into 1 is x plus 0, so x. First row, second column will be 0, 0, 0. Second row, first column will be 1 1s are 1 plus 3 3s are 9. 1 plus 9 is 10. Then second row, second column will be 1 into 0 is 0 and 3 2 is 6. That's it. Okay. Now, now he has told us that this AB is equal to BA. So I can write AB as x0, 3x plus 2 and a 6. This is equal to x0, 10 and a 6. Okay. Now since these two matrices are equal, the corresponding elements has to be same. Okay. So see, these are the corresponding elements. They are already same, 0 0. This is also same, 6 6. This is also same, x x. So this will also have to be same. So can I write 3x plus 2 is equal to 10? So I can write that 3x plus 2 is equal to 10. From this I'll get 3x equal to 10 minus 2, which is equal to 8. So 3x is equal to 8. Therefore x will be equal to 8 upon 3. So I wanted to find out x. They have asked me to find out x, and I got the x as 8 upon 3. And that is the answer for this question number 47. Okay. And let me check the answer. And yeah, it is 2 by 3. What is it? Yeah, it is 2 by 3. Now 8 upon 3 can be written as 2 by 3 also. This is in a mixed fraction form. This is improper fraction. Okay, fine. So that was question number 47. And let us move on to 48. 48. Now 48 is, if a X matrix is given to you as a K, 2, 2 and a minus K, and X square is given to you as 5 and then 1 0 0 and 1. You are asked to find out K. Okay, fine. So X is given to you and X square is this. Okay, so what I'll do is I'll first find out this X square using this X. X square will be equal to K 2 2 minus K times another X, that is K 2 2 minus K. Right? Now this should work out to first row first column, so it will be K square plus 4. Then first row second column will be 2K minus a 2K. Then second row first column will be 2K minus a 2K. And second row second column will be 4 plus K square. Okay, this happens to be my X square. Okay, but X square is given to you as 5 1 0 0 1. Now this I can take inside and write it 5 ones are 5, 5 zeros are 0, 5 zeros are 0, 5 ones are 5. Now this is also my X square, this is also my X square. So I can very nicely equate the two. Okay, so can I write K square plus 4 2K minus a 2K. Now this happens to be 0, 2K minus 2K. Okay, this 2K minus 2K also happens to be 0, and this is 4 plus K square. Okay, this will be equal to 5005. Now let me write this as 0. So K square plus 4 uh, K square plus 4, this will be 2K minus 2K is 0, this will be 0, this is 4 plus K. Okay, now this is equal to 5005. Now to find out K, I'll equate this with this. So I'll get K square plus 4 equal to 5. Or I can do this also. Okay, no issue. So let me do that also. 4 plus K square equal to 0. From here I'll get K square is equal to 5 minus 4 is 1. That means K is equal to plus or minus 1. Okay, 1 second. K square is equal to 1. This will give me K is equal to This should give me k is equal to root of 1, that is k is equal to plus or minus 1. Okay. From here, if you want to find out k square equal to minus 4. Now any square of any real number cannot be negative, so this is not possible. This cannot be possible. So my answer for k is equal to plus 1 or a minus 1. Okay. So that was the answer for question number uh, 48, and the answer in the book behind is k is equal to plus or minus 1. That's correct. Now we are left with only 2 more questions of this exercise to make it a half century. So let us come to question number 49. Now question number 49 says that a matrix B is given to you as a 3 3 first row, minus 1 second row. Okay. Sub question A is find k if b square is equal to kb. Okay, so this is the condition. We have to apply this condition to find out k. B sub question is find out m. Okay, find m if b raised to 4 is equal to mb. Okay, b raised to 4 is equal to mb. So let us tackle this question 49th. Okay, now b matrix is given to you. B square will first find out and b4 also will find out. Okay, so first let me find out b square. So b square will be equal to matrix B times matrix B, which is equal to 3 3 minus 1 times 3 3 minus 1. This should work out to first row first column will give me 3 3s are 9, 9 minus 3, 9 minus 3 is 6. Then first row and second column will give me 3 3s are 9, 9 minus 3 again 6. Then second row and the first column will be minus 3 plus 1, minus 3 plus 1, minus 3 plus 1 should be minus 2. Okay, and second row and the second column will be minus 3 again plus 1, that will be minus 2. So this is what I get as b square. Okay, now since b square is equal to k times b, according to A, it is given that b square is equal to k times b. Can I write this b square as 6 minus 2 equal to k times b? Can I write as 3 minus 1 right? Okay, so I'll end up with this situation where uh, 6 minus 2 equal to k times 3 3 minus 1 and I am supposed to find out this k. Now what can I do is this k I want to find out. Okay, now there is nothing like division of two matrices. Okay, you cannot divide this matrix by this matrix. Okay, you don't have such a provision. What I can do at the most is this 6, can I write as 2 into 3? This 6 also I'll write as 2 into 3. Okay, this minus 2 I'll write as 2 into minus 1, and this minus 2 also I'll write as 2 into minus 1. Okay, that I can do, and this I am keeping as it is, k 3 3 minus 1 done. Okay, next what I can do is from this particular matrix on the left hand side, from each and every element I can see that 2 is common, so I'll remove that common out. This 2 is common in each and every element, that I am bringing it outside. So I'll be left inside with 3 over here, 3 over here, minus 1 over here, minus 1 over here. And on the right hand side, I already have k times 3, 3, minus 1. Now if you carefully see this particular equation, this part of the equation and this part of the equations are identical. Okay, these two matrices are identical, 3, 3, minus 1, 3, 3, minus 1. So obviously because the whole thing is equal, this k should be equal to 2. So that gives me the answer for k equal to 2 for sub question A. For sub question B, the situation is different. You have to find out m, and he is saying that b raised to 4 is mb. So what I'll do is, first I'll find out what is b raised to 4. First let me write what is the equation given. B raised to 4 is equal to m times b. So b raised to 4 will be b square into a b square. Okay, matrix multiplication. So b square just now I had found out, and it was how much? It was 6 6 minus 2, isn't it? So this b square will be 6 6 minus 2, another b square will be 6 6 minus 2. Okay, b square, right? Perfect. 6 6 minus 2. Okay, now let us find out this product. So it will be first row, first column. So 6 6 are 36 plus minus 6 2s are 12. Okay, so 36 minus a 12 is a 4 and 2. So here I'll get a 24. Then this position I have to fill up. So first row and second column. So 6 6 are 36, again minus 12, so 24. Then second row and the first column. This will give me 6 into minus 2 is minus 12, plus minus 2 into minus 2 is plus 4. Okay, so minus 12 plus 4 will give me minus 8. Same way, this also I am going to get minus 8. Fine. So this is what I got as b raised to 4. But the question says that b raised to 4 is m times b, isn't it? So can I write this, instead of this b raised to 4, I'll write this 24 minus 8 equal to m times. Now b is how much? B is given to us as 3 3 minus 1. Okay, so it is 3 3 minus 1. Okay, now you are supposed to find out m. Okay, so to find out m, what I'll do, I'll try to make these two matrices equal. Okay, so let us see what I can do. This 24 can be written as 8 into 3. This 24 can also be written as 8 into 3, and this minus 8 can be written as 8 into minus 1, and this can also be written as 8 into minus 1. Okay, understood? There's no harm in doing that. This will be equal to m times 3 3 minus 1. Now you can see that from each and every element I can remove the 8 as a common out. Okay, so when 8 goes out, I'm left with a 3 over here, a 3 over here, a minus 1 over here, a minus 1 over here, and here I have a m, and I have 3 3 minus 1 and a minus 1. Now if you see properly, these two matrices are identical, so m has to be equal to 8. That was question number 29. No need of checking. I am very confident about it. And now coming to the last question, and that is 50th one. It is saying that a is equal to a 5, a 5, a minus 2 and a minus 2. Okay. Sub question A is you have to find out n. Okay. If a square is equal to na, and B part is you have to find out q if a cube is equal to q times a. Okay, so as usual, let us first find out what is a square first. Okay, a square. So a square will be a multiplied by a, and a is 5 5 minus 2. So this will be 5 5 minus 2. Now this will be first row, first column. 5 5 are 25, minus 10 is 15. First row, second column. 5 5 are 25, minus 10 is again 15. Second row, first column. Minus 10 plus a 4. Minus 10 plus 4 is minus 6. Second row, second column. Minus 10 plus a 4. So again minus 6. So this is what I get for a square. Now he is saying that a square is equal to n times a. So what I'll do is this a square, that is 15, 15 minus 6 minus 6. I'm going to equate with n times a. Now what was a? A was this 5, 5 minus 2 minus 2. Now from this 15, or rather 15, I'll write as 3 into 5. This also 3 into 5. This I'll write as 3 into minus 2. This will also be 3 into minus 2. Okay. This is equal to n times 5, 5 minus 2 minus 2. Now from the left hand side matrix, I will take 3 common out. So I'll be left with a 5 and a 5, minus 2 and a minus 2, equal to n times 5, 5 minus 2 minus 2. Now these two matrices are identical. This means that this n has to be equal to 3. That was A part of the question. Now let us go for the B part. B part says that a cube is equal to q times a, and you have to find out q. So first let me find out a cube. So a cube can be written as a square into a. A square, just now I got it in this question. A square. A square was 15, 15 minus 6 minus 6. Okay. So this a square will be this a square. 15, 15 minus 6 minus 6. This you have to multiply by one more a. And a is what? Yeah, a is 5, 5 minus 2 minus 2. So a is 5, 5 minus 2 minus 2, right? Chalo, let us go. 15 5s are 75 minus 15 2s are 30. So 75 minus a 30 has to be how much? 6 minus this 3, so 35. Here also you will get a 35. Now this second row and the first column, minus 6 into 5 will be minus 30, plus minus 6 into minus 2 will be 12. Minus 30 plus 12, which is equal to minus, should be how much? 30 minus 12, no? So 10 minus 2 is 8, right? And 2 minus 1 is 1. So it should be minus 18. This is also minus 18. Got it? So I got a cube as this. But the question says that a cube is equal to q into a. So this 35, 35 minus 18 minus 18, which is my a cube, is actually equal to q times a. And a is what? It is 5, 5 minus 2 minus 2. Now from this, 35, 35, I'll keep 5 as it is. So it will be 7 into 5. This will also be 7 into 5. This should be, this is what? 18, no? So, insert, no? There is something wrong over here. A cube is equal to 35, 35 minus 18 minus 18. 35, 35 minus 18 minus 18 equal to q times a. Okay. And a is 5, 5 minus 2 minus 2. This should be 9. Okay. This should not be 35. Let me check this. 70 minus 30. 75 minus 30 should be 45. Okay. Right. So, my bad. It should be 45. Right. This is 45. This is 45. Now 45 can be written as 9 into 5. Okay. So I'll write this as 9 into 5. This also will be 9 into 5. And this minus 18 can be written as 9 into minus 2. This also 9 into minus 2. This is equal to q times 5, 5 minus 2 minus 2. Now what I will do is from the left hand side matrix, I will take this 9 common in all the terms. I'll bring it out. I'll be left with 5, 5, a minus 2, a minus 2. Here q is outside and there's a 5, 5, minus 2, minus 2. Now you can see these two matrices are same, identical. So this Q has to be equal to 9. So the answer for the 50th one is Q is equal to 9. And with this, we end this exercise 1, which had 50 huge questions. And successfully we have completed these 50 questions. And in the process of this completion of these 50 questions, we have learned a lot about algebra of matrices, that is addition, subtraction, scalar multiplication and multiplication of two matrices. So algebra of matrices has been thoroughly done with, and I'm 100% sure that any student who is doing all these problems along with me, okay, will be now perfect in this algebra of matrices. The next thing that is going to come in this chapter is to find out the inverse of a matrix. So first I'll explain you what is the inverse of a matrix, and I'll tell you how to find out the inverse of a matrix. Okay, but that will be in the next video. So that's all for this particular session, and thanks for being with me. And if you like my video, please subscribe and press the bell button. And that's all. See you. Bye. Take care.